Alright, today let's have a look at solutions to homework of topic 12b. Okay, first question. In the diagram shown at right, arc AB is 40 degrees, arc CD is 103 degrees. And arc CD is 83 degrees. Find angle AED. Okay, first of all, we know that angle AED can be expressed as half of the sum of arc BC plus arc AD, right? We already know arc BC. So here, first of all, we need to find arc AD, right? So actually, arc AD can be found using 360 degrees subtracted by arc AB, arc BC, and arc CD. This gives us 134 degrees, right? So here is 134 degrees. And therefore we know angle AED is just 1/2 of BC, 103 degrees, plus AD, which is 134 degrees. And that gives us 118.5 degrees, right? Any questions? Alright, good. If no questions, let's have a look at the second one. Find the following diagram at right if arc XY is 78 degrees, arc XV is 32 degrees, and angle YWZ is 30.5 degrees. Okay, we need to find A, the measure of arc YZ, which is here, and then the measure of arc VZ, which is this arc here. Okay, first question. Since we know angle YWZ equals 1/2 of the difference between arc YZ and arc XV, right? We have 30.5 degrees equals 1/2 of YZ is unknown, and we know XV, right? And then we can find the arc YZ, which is 93 degrees, right? And then for arc VZ, you can find it again using 360 degrees subtracted by YZ, XY, and XV, right? And this gives us 157 degrees. Do you get it? Okay, if no questions, let's have a look at the next one. Question number 3. Given that arc XY is 75 degrees, this arc here, and angle, arc XYZ, the longer arc here, is 117. Here, this arc here. And arc YZW, okay, this longer arc here, is 173 degrees. Find each of the following angles. Okay, first we need to find angle YPZ. Okay, so first of all we have arc YZ is given by arc XYZ subtracted by arc XY, right? And this gives us 117 degrees. minus 75 degrees, which is 42 degrees. And we also have arc XW equals 360 degrees minus arc YZW minus arc YZ, and this is 112 degrees, right? And then we have angle YPD equals half of the difference between the arc XW and the arc YZ, right? This is what we have learned in our previous lesson. So this gives us 35 degrees. Did you get it? Okay, second question, we need to find angle YOZ. Angle YOZ can be given by 1/2 of the sum of XW plus the arc YZ, right? And this is 77 degrees, right? For the third question, angle XYW is actually 1/2 of the arc XW. Can you see that? And then first we need to find the arc XW. The arc XW equals 360 degrees minus YZW minus XY. Oh, sorry. We have already done this, right? So we can directly write angle XYW is 1/2 of the inscribed arc, which is arc XW, right? So that gives us 1/2 of 112 degrees, and this is 56 degrees. Okay, last one. The angle OWZ is inscribed in the arc OWZ here is inscribed in the arc YZ, right? Therefore, we have angle OWZ is just 1/2 of the inscribed arc YZ. We have already calculated YZ here, so that is 21 degrees for angle OWZ. Any questions? Okay, no questions. Let's have a look at this. Question number 4. Points U and I are on circle O. Okay, first. Such that major arc UI is twice as long as minor arc UI. P is outside circle such that PU and PI are tangent to circle O. Okay, first let's briefly draw a diagram to show the situation here. So this is circle O. So we need to have 2 points U and I. And major arc UI is twice as long as minor arc UI, right? And then there are 2 segments like this. This is point P, right? Okay, first of all, we need to find the minor arc UI. So if we let minor arc UI equals x, therefore major arc UI has a measure of 2x, right? So if this is x, this is 2x. Then we know 3x equals 360 degrees. Then x equals 100 degrees, right? But first of all, you need to state what is your x. So let x be minor arc UI. Then we have the minor arc UI is 120 degrees. And then we can consider second question, find angle UPI. Okay, so angle UPI is given by 1/2 of the difference between the major arc UI and minor arc UI. So that's 1/2 of 240 degrees minus 120 degrees, right? And that gives us 60 degrees. That's the angle UPI. Did you get it? For question C, find angle PIO. Okay, the segment IO is a radius, right? And PI is a tangent to that circle. So that means this angle here must be 90 degrees, right? So we could say because UI is perpendicular to segment PI, then we know angle PIO equals 90 degrees. Then next question, find angle IOU. So again, because UO is also a radius, so that angle here is also 90 degrees, right? So from the polygon UPIO, we have angle IOU equals 360 degrees minus angle PIO minus angle IPU and angle OUP, right? And that gives us 120 degrees. Okay, last one, question E. So we could make use of the triangle PIU. So triangle PIU is actually a isosceles triangle, right? So angle PIU is called angle PUI, which is half of 180 degrees subtracted by angle IPU, right? And this gives us 60 degrees. You get it? Alright, if you don't have any questions, let's see the next one. Question number 5, again, which is also a basic question. So basically we have a circle O, we have a point T, which is outside circle O. So T is here. We know X is on the circle such that Tx is tangent to circle O. So this is point X. Center of the circle is O. And the radius of the circle O is 6 and Tx equals 12. We need to find the length of TO. Okay, so let's connect TO. And apparently because XT is tangent to that circle and XO is a radius of that circle, then we know that this angle must be 90 degrees, right? So OT, you can consider right triangle XOT. So we can say because XO is perpendicular to XT, then we know angle TXO equals 90 degrees. And then we consider the right triangle XOT. We have TO squared equals XT squared plus XO squared, right? And we know XT is 12, so 144 plus XO is the radius, which is 6. So 6 squared is 36. So that gives us 180, right? Therefore, we know the length of TO equals square root of 180, and this gives us 6 times square root of 5. You get it? A pretty straightforward question, right? Okay, if you don't have any questions, let's have a look at the next one. Question number 6. Okay, according to the description, again we have a circle G. And we have we have a point X, which is outside of the circle. And we have some tangent lines, right? So this is point X. We have y-axis tangent to that circle, and x is also tangent to that circle, and y and z are on the circle. Given that this angle here, yxz is 51 degrees, find the measure of the minor arc yz. So at this part, the measure of this arc, or or the other one, we don't know which is longer yet, right? So we could let the minor arc yz equals x, so we need to find the value of x, right? So in that case, the major arc yz should equal 360 degrees minus x, right? And angle yxz can be given by a half of the difference between the major arc and the minor arc, which is 360 degrees minus x and minus another x, right? Since we are given angle xyz equals 51 degrees. So basically we have one equation in terms of x, only one unknown variable, right? Therefore we know 51 degrees equals 180 degrees minus x. Therefore we know x equals 129 degrees, right? Okay, have a look at the solution here. Any questions, just let me know, okay? Okay, if you don't have any question, let's have a look at the next one. Okay, question number 7. First of all, we have a circle. O is tangent to all 4 sides of a rhombus A, B, C, D. Okay, let's draw a circle to illustrate the situation here. We have a circle and we have a rhombus. Alright, and let's label these points A, B, C, and D. The length of AC and AB is given. First of all, prove that segment AC and BD meet at O. Okay, let's connect AC and then BD. So we can prove it like this. We could draw a perpendicular line like this and like this. So for question A, we could let the foot of the altitude from O to segment AB be X, and the foot of the altitude from O to AD be point Y. Since circle O is tangent to both AB and AD, right? Then we have OX must equal OY, because they are the radius of that circle, right? And we also have angle OXA equals angle OYA, which are 90 degrees, right? We also have OA equals OA. Then we have triangle OXA is is congruent to triangle OYA by HL congruence. Therefore, we have angle OAX must equal angle OAY, right? So what does this tell you? This tells us that O is on the angle bisector of angle BAD. And similarly, you can prove using the same method, O must be on the angle bisector of all 4 angles of the rhombus. Since the diagonals of a rhombus bisect the angles of a rhombus, we can conclude that O must be on both diagonals of the rhombus, right? Therefore, O must be on both diagonals of the rhombus. Did you get it? Okay, that's the first question. And then we can consider the second part. Okay, let's erase this first. Second question asks to find the area of circle O. Okay, first of all, because ABCD is a rhombus, we know that AC must be perpendicular to BD, right? Sorry. Let's keep the diagram. Okay, let's write question B. So we know ABCD is a rhombus. Then we know that segment AC must be perpendicular to BD because they are the diagonals of a rhombus, right? Therefore, we know angle AOB must be a right triangle. Also, ABCD is a parallelogram, right? Because rhombus is also a parallelogram. And then AC and BD bisect each other. At point O, right? Therefore, we know AO equals a half of AC, which is 12. And from the right triangle ABO, we have OB equals 9. AO equals 12. AB equals 15. Okay, so in right triangle ABO, we have BO equals square root of AB square minus AO square. And this gives us 2 5 minus 1 4 4, right? And that's 81. Square root of 81 is 9. So BO equals 9, right? So we have the area of the triangle AOB is given by a half of 9 times 12, which is 54, right? So we now can find the distance from O to segment AB. So we have OX equals twice of the area of AOB over the base AB, right? Which is 2 times 54 over AB 15. And this gives us 36 over 5. Therefore, we know the area of circle O can be given by OX squared pi, right? OX is the radius. So that gives us 1296 pi over 25. Did you get it? Okay, have a look at the solution here. Let me know if you have any questions, okay? All right, if you don't have any questions, let's consider next one, question 8. So in the figure at right, AB is tangent to both O and P. The radius of O is 8, the radius of P is 4. OP is given to be 36. Find length of AB. Also, a common tangent like AB here is sometimes called the common integral, the common internal tangent of the two circles. So here we have tangents and we are looking for a length, right? So we could build right triangles by connecting O and P. And also let's connect O and A, because if we have a tangent of circle, usually we can make use of some right triangles by connecting the corresponding radius, right? So if you let T be the point where AB and OP meet, since angle ATO equals angle PTB, and angle OAB equals angle PBA equals 90 degrees. We have triangle AOT must be similar to triangle BPT by AA similarity, right? So we could let OT equals X, and then we have, so if OT equals X, we have PT equals OP minus OT. This is 36 minus X, right? So from our similarity, we have OT over OA equals PT over PB, right? Therefore, that means X over 8 equals 36 minus X over PB, which is 4. Of course, you can solve X equals 24, right? So that means the length here equals 24. And therefore, we have AT equals square root of OT squared minus AO squared, which equals 16 square root 2, right? And also TB equals square root of PT squared minus PB squared, and that equals 8 square root 2. Therefore, we have AB equals AT plus TB, and that equals 24 square root 2. You get it? Alright, if you don't have any questions, let's have a look at question number 9. So here we have 5 circles in the diagram congruent, and ABCD is a square with side lines 4. So 4 outer circles are each tangent to the middle circle and to the square on the 2 sides as shown. Find the radius of each of the circles. Okay, so here, let's suppose this is center of the middle circle. By symmetry, we know the center of the middle circle is equidistant from the vertices of the square, right? So that means this center must be on both diagonals. So if you simply connect B and D and A and C, we know the point of intersection of the 2 diagonals is actually the center point of the middle circle here, right? And then let's consider the center of this circle here. Suppose we call this point E. And point E is equidistant from AB and AD, right? Because the circle is tangent to the 2 sides of that square. So if you draw the 2 altitudes, that's also the radius. So these 2 distances are equal. So E is equidistant from AB and AD. It must be on the angle bisector of angle BAD, right? Diagonal AC bisects angle BAD. So it must pass through E. Similarly, AC must pass through this center G. Center G is the center of that circle here, right? So drawing altitudes from E and G to AB and CD. So let's call this point Y and call this point X. Then we form 45, 45, 90 triangles, letting the radius of each little circle be R. So let the radius of each of the circles be R. Then we could establish some equation in terms of R, right? Then we have Gx equals Ey equals R, and Ae equals Cg, which is R square root 2, right? Because they are in a 45, 45, 90 triangles. We also have Eg equals 1, 2, 3, 4, 4R, right? Because this segment includes one radius of each of the circle E and G and the diameter of the center circle. Therefore, we have the following relationship. AC equals 4r plus 2r square root 2. Since we also have AC equals AD square root 2, which equals 4 square root 2, we then have 4r plus 2r square root 2 equals 4 square root 2, right? And therefore we have r times 2 plus square root 2 equals 2 square root 2. So we have r could be solved, which is 2 square root 2 over 2 plus square root 2. And remember, we need to rationalize the denominator. So that gives us 2 square root 2 minus 2, right? That's the final result for the radius of each of the circles here. Did you get it? Alright, if you don't have any question, let's consider the next one. Question number 10. Okay, again, basic understanding of the properties of the arc and corresponding angles. First, find angle, find x in each of the following. In the first question, if you want to find the angle ABC here, we know x equals half of the inscribed arc AC, right? So first of all, you need to find the inscribed arc AC. So AC here equals 360 degrees, subtracted by 120 degrees, subtracted by 190 degrees, and this gives us 50 degrees, right? Therefore, we have x equals a half of the inscribed arc AC, which gives us 25 degrees. You get it? And then second question. So here, once you know this angle is 90 degrees, this angle is 50 degrees, then in that triangle IHJ, we know this angle must be 40 degrees, right? Then actually you know the angle here, and we want to find inscribed arc IH. So first of all, angle J equals 180 degrees minus 90 degrees minus 50 degrees, which is 40 degrees. Then we know that equals a half of the inscribed arc X. Because of this, we know X is twice of angle J, which equals 80 degrees, right? Okay, then question C. So here we have RS equals, so this little strokes means they are equal. So RS equals RT, right? Because of this, we have arc RS equals arc RT, right? Furthermore, the arc ST equals twice of angle R, which equals 80 degrees. So adding all the arcs of the circle gives us x plus 80 degrees should equal 360 degrees, right? And therefore we know x equals half of 280 degrees, which is 140 degrees. You get it? Okay, then question D. In the diagram below, angle ACB is given. which is 10 degrees here. So here, because we have OA equals OB equals OC, we deduce that O is the center of the circle, right? You see why? Okay, and then arc AB equals twice of angle ACB, which equals 20 degrees, right? And therefore we know angle AOB equals arc AB, which is also 20 degrees. Did you get it? Okay, then question E. So because W, X, Y, Z are all on the circle here, so W, X, Y, Z is called a cyclic quadrilateral. Then we have angle W plus angle Y must equal 180 degrees, right? Therefore, we have X equals 180 degrees subtracted by the opposite 120. This gives us 60 degrees, right? Any questions? Okay, if not, let's consider the last one of question number 10. So here we know angle QPR and angle RSQ are inscribed in the same arc. Can you see why? QPR is here, which is inscribed in this arc QR. QSR or RSQ is also inscribed in this arc RQ, right? Therefore, you can see angle QPR equals 20 degrees. Means X equals this angle here. Did you get it? You can directly write X equals angle QPR, which also equals angle QSR, and this is 20 degrees. Right? Any questions? Okay, then let's consider next one, question 11. Again, you are given a series of diagrams and we need to find X in each of the following diagram. Assume all the lines that look tangent lines are indeed tangent lines. Okay, first of all, here we know AC equals, it says segment BC equals DE, right? Because of this, we have arc DE also equals arc BC, which is X. So here this arc is X as well. Therefore, we know arc CE can be given by 360 degrees minus X minus 31 degrees minus another X, which can be simplified to 329 degrees minus 2X. And since angle A equals a half of the difference between arc CE and arc BD, we have 24 degrees equals half of 329 degrees minus 2x minus 31 degrees, right? Which can be simplified to 149 degrees minus x. and therefore we can solve x equals 149 degrees minus 24 degrees, which then gives us 125 degrees. Did you get it? Any questions? Alright, then if no questions, let's consider the question B here. So in this diagram, since we have angle WZX equals half of the sum of the two arcs WX and VY, right? Then we have 90 degrees equals half of 155 degrees plus 2x. This is what the diagram tells us, from which we can solve x to be 12.5 degrees, right? Alright, then let's consider question C. Okay, in this case, arc PS equals 360 degrees minus 61. Sorry. Subtracted by 133 degrees. Alright. And this gives us 166 degrees, right? And therefore we have x equals angle Q, which is half of the difference between arc PS and arc PR. And this equals 52.5 degrees. Any questions? Oh, okay, next one. We know the minor arc GI equals x, right? So, okay, we know minor arc GI equals x. Then the major arc GI must be 360 degrees minus x, right? And therefore we have the following relationship. Angle GHI equals a half of the difference between these two arcs, which is 360 degrees minus x, which equals 180 degrees minus x, right? And we also know that angle is actually 45 degrees, so we can solve x, right? Therefore we know x equals 135 degrees. Any questions? Okay, if no questions, let's consider the last one of question 11. So here we have angle K can be given by a half of the arc JL, which equals angle JLI, which is 43 degrees, right? Because angles K and JLI are inscribed in the same arc. Which is this arc here. And therefore, from triangle JKL, we have x equals 180 degrees, subtracted by 43 degrees, subtracted by 31 degrees, and this gives us 106 degrees, right? Any questions? Alright, if no questions, let's take a 10 minutes break, and after that, please return for the second half of this lesson. Alright, see you in 10 minutes. Okay, next let's have a look at question number 12. So here AC is the diameter of circle O. Given angle ACB is 58 degrees and BD equals CD. Find the following: A. Arc AB, B. Angle BAC, and C. Angle DBC. Okay, first question. Arc AB can be given by 2 times the angle ACB, right? Because angle ACB is inscribed in that arc. So that gives us 116 degrees. Okay, second question, angle BAC. So first of all, we know arc BC equals 180 degrees subtracted by 116 degrees. And this gives us 64 degrees, right? And therefore angle BAC is given by half of BC. And this is 32 degrees, right? And for question C, we know angle D equals angle A, which equals 32 degrees. And since triangle BDC is isosceles with DB equals DC, we have angle DBC equals half of 180 degrees subtracted by 32 degrees. And this gives us 74 degrees, right? Any questions? Alright, no questions. Let's see the next one. Question 13. AT and BT are tangent to circle O as shown at right. Given AT equals 6 and arc AB is 120 degrees, which means this angle here is 120 degrees, right? Find OT. And the area of OATB. Okay. Since TA and TB are tangent to that circle, both angle A here and angle B here are 90 degrees. So we can divide the area of OATB into 2 right triangles by drawing OT, right? Since AT and BT are tangents to the same circle from the same point T, we have AT equals BT, right? We also have OA equals OB, and of course OT equals OT. Because of this, we have triangle OAT is congruent to triangle OBT, right? By SSS, congruent. Therefore, we have angle AOT equals angle BOT, which equals a half of angle AOB. And that gives us 60 degrees, right? So both of our right triangles are 30, 60, 90 triangles. And since AT equals 6, we have OA equals AT over square root 3, which gives us 2 square root 3, right? And we also know OT equals 2OA, which is 4 square root 3, right? And we also have angle ATB equals angle ATO plus angle OTB, which gives us 6 degrees. And finally, we have the area of OATB is area of triangle OAT plus area of triangle OBT. And this is 1/2 of OA times AT plus 1/2 of OB times BT. And eventually we have the area is 12 square root 3. Okay, have a look at the solution here. Any questions, just let me know, okay? Okay, if no questions, let's consider next one, question 14. In the circle at right, AB is parallel to CD. AD is a diameter of that circle. And AD equals 36. What is the length of AB? Okay, so here we first know angle A equals 50 degrees. Angle A is inscribed in arc BD. Then we know BD must equal twice of that angle, right? So that's twice of angle A, which is 100 degrees. Since AD is a diameter, we know that, okay, because AD is a diameter, we know that AB must equal 180 degrees subtracted by the arc BD, right? And that gives us 80 degrees. And therefore, the arc AB is just 80 degrees over 360 degrees, which is 2/9 of the whole circle. Since the circumference of that circle is AD times pi, which is 36 pi, right? Then we know the length of AB. So here note we are finding the length of AB, not the degree measurement of AB. So the length of AB here is given by 2/9 of the entire circumference, which is 36 pi, right? Therefore, that is 8 pi. All right, again, have a look at the solution here. Any questions, just let me know. All right, in that case, let's have a look at the next one if you don't have any questions. So here ABCD is a parallelogram. BC extended past B meets the circumcircle of triangle ABD at point E as shown at right. Can you prove ED equals CD? Okay, first of all, we know that ABCD is a parallelogram then we have angle A equals angle C, right? And also since angle E and angle A are inscribed in the same arc, BD, we have angle E equals angle A, right? And therefore we know angle E equals angle A equals angle C. So triangle EDC is isosceles with ED equals CD. Therefore we have proved ED equals CD, right? Any questions? Okay, if no questions, let's have a look at the next one. Okay, given angle VWZ equals 81 degrees here, and angle WZX equals 38 degrees here, can you find the following? A, angle VXZ. Okay, first of all, we know angle ZWX equals 180 degrees subtracted by angle VWZ, which equals 99 degrees, right? And in triangle WXZ, we have angle VXZ equals 180 degrees minus angle WZX minus angle XWZ. And this gives us 43 degrees, right? Okay, second question, find angle WYZ. The angle WYZ is inscribed in that arc WZ. So WYZ equals a half of WZ, which is angle WXZ. And that gives us 43 degrees as well. Question C, find angle XZY. So okay, let's call this point here as O. So let the point of intersection of the segment XZ and WY be point O. Then right triangle OZY gives us angle XZY equals 90 degrees subtracted by angle OYZ, and that is 47 degrees, right? Okay, then question D. First of all, we have angle WYX equals a half of WX, and this gives us also equals WZX, which equals 38 degrees. And we know that the angle WYZ equals 43 degrees. Therefore, we have angle WYZ equals angle WYX plus angle WYZ, which equals 81 degrees, right? Okay, last question, E. We need to find the angle WXY. So since WXYZ is a cyclic quadrilateral, we have angle WXY plus angle WZY equals 180 degrees, right? And since angle WZY equals angle WZX plus angle XZY, which equals 85 degrees. We then have the following relationship. Angle WXY equals 180 degrees subtracted by angle WZY, right? And this gives us 95 degrees. So have a look at the solutions here. Any questions, just let me know, okay? Alright, if no questions, let's have a look at next one. Question number 17. Right triangle XYZ and its incircle are shown at right. As shown, Z is 6 units from the point where the incircle touches XZ, and Y is 3 units from the point where the incircle touches XY. Find the length of YZ. So first of all, let's label this point here as A, and tangent point B, tangent point C here. We'll label the points of tangency as shown here, and in that case we have YA equals YB, and of course ZA equals ZC, right? And then we have YZ should equal YA plus AZ. Well, YA equals YB, so we have YB plus, well, AZ equals ZC, right? So that's YB plus ZC. And we know YB is 3 and ZC is 6. So eventually YZ is 9, right? Also very straightforward question here. Alright, if no questions, let's have a look at next one. Circles A and B are tangent at point C, and P is on circle A and Q is on circle B such that segment PQ is tangent to both circles. Given AC is 3 and BC equals 8, so basically we know the radius of the both circles here. Okay, first of all, we could connect PA and QB, right? And PA is the radius of that circle, QB is the radius of the larger circle. So if PQ is tangent to both circles, we know this angle is 90 degrees and this angle is also 90 degrees, right? And we also could find a point X on BQ such that QX equals PA, which is 3, right? So we could find X such that QX equals PA equals 3. This is possible, right? Now let's call this point X. Then we know that PA is parallel since PA is since PA is parallel to QB, because this angle is 90, this angle is 90. Sum of these two angles equals 180. So PA is parallel to QB, or, well, let's use QX here. And also PA equals QX, right? Therefore, we know PQBA is a parallelogram. Also, because one of the internal angles is 90 degrees, and actually parallelogram PQBA is a rectangle, right? And therefore we have AX equals PQ. And therefore, as long as you can find AX, then you can find PQ. So note that this angle is also 90 degrees, right? So if we consider the right triangle ABX, if you want to find AX, you need this length BX and this length AB, right? So first of all, we know AB equals AC plus BC, and this gives us 11. And bx equals the difference between the two radius, which is qb minus pa, and this gives us 5, right? And therefore ax equals square root of ab square plus bx square, and this gives us 121 plus 25, and that's square root of 146, right? Oh, sorry. This should be a minus sign here, because AB is hypotenuse. And that's actually square root of 96. And simplify to 4 square root 6. And again, therefore, PQ equals AX, which is also 4 square root 6, right? Did you get it? Again, if you can find any line that is tangent to any circle, we could make use of the corresponding right triangles. Alright, if no questions, let's see the next one. Okay, given a circle of radius 2, there are indefinitely many line segments of length 2 that are tangent to the circle at their midpoints. Find the area of the region consisting of all such line segments. So this is a question from AMC 12. Okay, first of all, let's draw a circle to illustrate the situation here. We could let O be the center of our circle and AB be one of our tangents. So if you don't have to consider all the tangents. So let's consider only one tangent here. So suppose we have a tangent line, tangent segment AB. So since AB is tangent to that circle at its midpoint, the radius from O to the midpoint of AB is perpendicular to AB, right? You should be able to see that. So this angle here is 90 degrees. From the right triangle, so let's call this point T. From the right triangle OTB, we have OB equals square root of OT squared plus TB squared, right? And this is square root 5. And similarly, OA is also square root 5, right? And the endpoints of all of our tangent segments are basically square root 5 away from O. Therefore, the endpoints of our tangents trace out a circle with a radius of square root 5. The segments therefore fill out the region between the circle with radius 5 and the original circle, which means if you consider all the endpoints, then that consists another circle outside the original smaller circle, right? All the endpoints of the tangent lines form another circle outside. So basically, we're trying to find the area of this region, which is the difference between the two circles. So the area of the desired region can be given by square root 5, this radius of the larger circle, which is here, times pi, subtracted by the radius of the smaller circle times pi. And this gives us exactly pi, right? Okay, have a look at the solution here. Any questions, just let me know, okay? Alright, if no questions, let's see the next one. We are given points A, B, C, and D in the plane such that AD is 13, while AB equals BC equals AC equals CD equals 10. Find angle ADB. So first of all, it's better to draw a diagram to illustrate the situation here. Suppose we have a circle. Okay, if we know AB equals BC equals AC, that means the distance from point C to point A, B, D are equal. So C must be the center of that circle, right? So let's suppose C is here. And A is here, B is here, and another point D is here. And also let's connect A and B. Connect D and B. Then connect A and D. Okay, so you should state that because BC equals AC equals DC equals 10, we know the circle with center C and radius 10 goes through AB and D. As the diagram shown on the left. Also, we know that angle ABC is equilateral. And then, of course, angle ACB here equals 60 degrees, right? So the reason we want to find angle ACB is to find the arc AB here. Arc AB is also 60 degrees. Since angle ADB is inscribed in this arc, we have angle ADB is just 1/2 of the inscribed arc AB, which gives us 30 degrees. So eventually, the angle we are looking for equals 30 degrees, right? No questions. Let's see. Next one. Question number 21. Okay, so we are given two squares. Area of the two adjacent squares are 256 square inches and 16 square inches respectively, and their bases lie on the same line. What is the number of inches in the length of the segment that joins the center of the two inscribed circles? Okay, first of all, we could label the centers of the circles like this in order to facilitate our discussion. So let's label this point as T, this point here as I, and next we could, because we have some tangent lines to the circles, right? So we could draw some perpendicular lines, or we could just join the center of that circle to the point of tendency like this. And suppose the point of tendency here is V, point of tendency here is W. If we connect TV and IW, TV is perpendicular to the base, IW is also perpendicular to the base of the square, right? And then we could find a point X here. Such that Vx equals IW, and then connect these 2 points. So because XV is parallel to IW and also XV is equal to IW, then XIWV is actually a parallelogram, right? And one of its internal angle is 90 degrees, so we know that. Okay, so I'm not gonna write all of the descriptions here, okay? So according to our description here, we know that XIWV is a rectangle. Therefore, we know Xi equals VW, right? So if you want to find the length of segment that join the centers of the 2 inscribed circles, basically we need to find the length of Ti, right? Okay, if you know the area of the larger square is 256, then we know the length of that square is square root of 256, which is 16. And we know the length of the smaller square is square root of 16, which is 4, right? Okay, then we know that VW equals the radius of the larger square, which is 1/2 of 16, which is 8. And VW also equals XI, right? So XI equals 8 here. And we also know TV can be given by the radius of the larger square subtracted by the radius of the smaller circle here is 1/2 the side length of the smaller square, and this gives us 6. Oh, sorry, made a mistake here. This length is the sum of the 2 radius, so 1/2 of 16 plus 1/2 of 4, right? And that's 10. And that also equals xi, so that's a 10. Therefore, we can easily find the length of ti, which is square root of tx squared plus ix squared, which equals square root of 16 plus 100. And that's 2 square root of 34, right? Any questions? Alright, if no questions, let's have a look at the next one. Okay, in this question we have 3 of the sides of ABCD, which are tangent to the circle shown at right, given that AB equals 6, BC equals 7, and CD equals 8. AD is 9. So there are a lot of given information here. We need to find CY plus DX. So where is CY? CY is here. Plus DX. DX is this length here. Okay, suppose, well, let's label this point as Z here in order to facilitate our discussion. So first of all, let's state what is point Z. So we let segment AB touch the circle at point Z. We are given that BZ plus AZ equals AB, which is 6, right? We also have BZ equals BY and AZ equals AX, right? Because tangents from the same point to the same circle are equal. So given this information, we have the following relationship. So CY plus DX is the one we're looking for. That equals BC subtracted by BY plus DA minus AX. And rearranging this gives us BC plus DA minus BY minus AX. And we know BC is given, which is 7. BA is 9, right? Then minus BY. BY is actually BZ. And then minus AX. AX is actually AC, so minus AC. Which equals 7 plus 9 minus BZ plus AZ, right? And this gives us 16 minus BZ plus AZ equals 6. And this gives us 10 eventually, right? So the length of CX plus CY, CY plus CX is 10. You get it? Alright, if no question, let's have a look at the last one. Question number 23. Chord CE is a segment of the perpendicular bisector of radius OA of circle O. AX is diameter of O. Find angle OCX. Okay, first of all, let's draw a circle to illustrate the situation here. We have a chord CE. So let's suppose this is our chord CE. And chord CE is a segment of the perpendicular bisector of radius OA. Okay, suppose this is radius OA. And this angle here is 90 degrees. Again, let's also connect O and C. Connect these 2 points. AX is diameter, so X is on the circle as well. AX cross the midpoint, the center of that circle O. So since C is a perpendicular bisector of radius AO, we have OY must equal a half of OA, right? Which equals a half of OC as well. And therefore, right triangle OYC is actually a 30, 60, 90 triangle, right? And since we have angle COY, let's call this point Y here. Angle COY equals 60 degrees. We have we have arc AC also equals 60 degrees, right? Therefore, we have angle CXA equals a half of the inscribed arc AC, which is 30 degrees. From the isosceles triangle OCX, we have angle OCX equals angle OXC, which equals 30 degrees, right? So in that way we can solve angle OCX. Okay, again, have a look at the solution here. Any questions, just let me know, okay? So basically these are the solutions to all of the questions for topic 12.